So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. I hope you guys are doing fine. Welcome to another physics lecture, and we have already discussed the topic of section 1, motion, forces and energy, section 1.1 to 1.2, 1.3 and 1.4. So today we are going to start with our new section, subsection basically, that is section 1.5 forces. Now this subsection is very long, so and some of you were saying that the videos shouldn't be too long, so I'm going to be dividing this section 1.5 into 2 or 3 videos so that the lecture is not very lengthy and it's easier for you to watch. Anyways, so this is section 1.5.1, balanced and unbalanced forces. Now the first thing that comes to mind is what exactly is a force. So a force is a push or a pull. When you're pulling something or you're pushing something, you're giving that object some force, you're providing some push to it, or you're providing some pull to it. That push or that pull is known as a force. A force can do the following things: it can make a stationary body move, it can change the speed or acceleration of a moving body, it can change the direction of motion, or it can change the size or shape of a body. It is a vector quantity and its SI unit is Newton. So these are the main types of forces. The gravitational force, which is an attractive pull towards the center of the earth or any other planet or any other object having a gravitational field. The electromagnetic forces, which exhibit between moving or stationary electrical charges. It can be electrical or repulsive in nature. Then we have nuclear forces or strong forces that exists between the subatomic particles such as electrons and protons. And then we have a fourth type of force that is known as weak forces, that is responsible for radioactive decay. Basically this is also known as weak nuclear force. And about these two types of forces are not really a part of your syllabus, but just as a bit of extra knowledge, I've included them because these 4 are the standard types of forces that are there in our universe. Then we have 2 things. One one is a contact force and another one is a non-contact force. These four forces are supposed to be non-contact forces, because in order to apply these, the two objects do not have to be in direct contact with each other. They can affect an object from afar as well. Like if you are not standing on the surface of the earth, it's not necessary for the gravitational field to affect you while you're standing on the earth. If you jump in the air, you're still affected by the gravitational field. If you if you climb a high building, you're still affected. If you're floating, if you are let's suppose gliding in the air in an aeroplane or through a glider or through a parachute, your feet are not touching the ground, but still you are being affected by the gravitational force. So these four type of forces are known as non-contact forces, as they do not need two objects to be in direct contact with each other in order for the force to be applied. Whereas these forces which we are going to study now, they are known as contact forces, as they only work when two objects are in direct contact with each other. A contact force is perpendicular to the surface experienced by a body when it is in physical contact with something else. Now, the first type of contact force is supposed to be friction. It acts in the opposite direction to the direction of motion of a body. For example, if you are pushing an object and it is going in this direction, then friction would be in the opposite direction, towards the left hand side. And it is a resistive force acting between bodies that tend to oppose motion or that tend to slow down an object. Next is a drag force, or a viscous drag, or a viscous force, or air resistance. Again, when a solid moves in a fluid or air, it will experience a resistance to its motion depending upon its speed. That resistance is known as viscous force or air resistance. When a person or a solid object is moving in air or in liquid, the molecules of this solid object bump into the molecules of the air or the gas or the liquid. Hence, this object tends to slow down over time. This is known as air resistance or viscous force. Then we have tension force. Tension force is a bidirectional force, and it is always directed away from the object and along the length of the string. For example, if an object is being hanged by a rope or a string, then the force in that string or that rope would be known as the tension force, and it would be bidirectional. The object would be applying some force onto the string or the rope, whereas the string would also be applying a force to the point, to the ceiling, or to the tabletop where it is being connected. Now, 2 points to remember when you are solving a question about forces. Thrust is a sudden driving force in a specific direction. Thrust is basically a huge push to something that kick starts an object's motion. Whereas and plus, the forces on an object can be represented in a free body diagram. This is a free body diagram which basically represent different types of forces acting on a body in form of arrows. Then we have the Newton's first law of motion. A body will continue in its state of rest or uniform motion in a straight line unless an external force acts on it. And while we are talking about the resultant force, you should know how to add different types of forces together, as you will be frequently given such type of free body diagrams in the paper, and you will be needing to find the resultant forces. If the forces are in the same direction, then simply add on the numeric part. Like this force is towards the right hand side, and so is this force, and one is of 10 Newton, the other is of 20 Newton. So the resultant force would become 30 Newton towards the right hand side. They were in same direction, so they would directly be added on. The effect on a body produced by two or more forces will be same as the effect produced by their resultant force. Hence we say that F resultant equals to F1 plus F2 up to Fn. No matter how many forces are acting in the same direction, we simply add them together. Adding forces in opposite direction: when you are adding forces which are acting on an object in opposite direction, we simply subtract them from each other, and the result is the resultant force. For example, this object has two forces. One is towards the right hand side of 20 Newton, the other is towards the right hand side of 40 Newton and towards the left hand side of 20 Newton. So 40 minus 20 would be the 20 Newton would be left, and the direction would be wherever the bigger force was going, like this. Whereas in form of this second free body diagram, on the right hand side a force is being applied of 20 Newton, and same is the force on the left hand side, so the resultant force would be 0 and the object would not move from its position. Forces acting at an angle to each other. Use the parallelogram law of vector addition to find the resultant force. Ensure that both forces are drawn to scale and start at same point. Using head to tail rule, join them into a parallelogram. The resultant force would be the diagonal of the parallelogram, like this. These were the two forces. We joined them, we rearranged them in form of a half parallelogram. Then we extended the forces in order to complete a parallelogram, and the resultant force would be the length of the resultant force would be the magnitude of your resultant force. So make sure that you take a proper scale and draw it up to the mark, up to a scale. And if you have forces at right angle to each other, then you can simply use the Pythagoras theorem, like this. These were the two forces. We have arranged them in form of a right angle triangle, and now we can use the Pythagorean theorem like we have discussed in our previous videos as well, and we can find the magnitude of this hypotenuse, and that would be our resultant force. Newton's second law of motion. The resultant force acting on a body produces a net acceleration and causes the body to accelerate in the direction of the resultant force. And this is usually summed up as a formula: force equals to mass into acceleration. When two or more external forces act on an object, a net resultant force is produced, which causes change in speed or velocity of an object, and this acceleration is produced in the same direction as the force itself. Hence, we often use it whenever you are given a question where you are either asked about force, mass or acceleration of an object, whereas you are given the other two values in the question, then you have to apply this formula. Then we have the Newton's third law of motion, that if a body A exerts a force on body B, then body B exerts a force of same magnitude but in opposite direction on body A. Means every reaction has an equal but opposite reaction. Force always occurs as a pair of action and reaction forces. These forces always act on different bodies but in opposite direction and having the same magnitude. For example, if a rocket or a missile is moving forward, then over here the two forces would be the engine is pushing it forward, whereas the exhaust flow is pushing it backward. Or you can say the air resistance would be pushing it backward, whereas the engine would be trying to thrust it forward. Example question: you are shown a car with a driving force and an opposing force or a friction of 600 Newton, and it is traveling at 30 meters per second, and calculate the distance traveled by the car in 10 seconds. Distance equals to speed into time. As you know, the formula is speed equals to distance over time, so we just rearrange it, and we are given the speed 30 meters and the time is given as 10 seconds. 30 into 10, 300 meters. State the value of the driving force produced by the engine for a steady speed. If the object is moving at a steady speed, that means the forward force and the backward force have been balanced out. Since the opposing force or the backward force is 600 Newton, then the driving force would also have to be 600 Newton, so the car can continue at a steady speed without any change in its speed, or a car can keep on moving at its current state of motion. Hence, the car will have to produce a force of 600 Newton. Explain why the car slows down when it climbs up a hill even though the driving force is unchanged. When you're going up the hill, gravity have also been included in the equation. As you go up, the gravity tries to pull the car backwards or to downwards. Hence, the total backward force have been increased, whereas the driving force is still the same, unchanged as given in the question. Hence, the car is slowing down. While on the level road and traveling at 30 meters per second, the driving force becomes 0. The mass of the car is 800 kg. Calculate the deceleration of the car. Now we're given the mass and we're given the speed, which is not really necessary over here, so we can ignore it. As we have to calculate that deceleration, we'll apply the formula F equals to ma, and we'll rearrange it as we have to find a. So a would be F divided by mass, force divided by mass. This is a 2-mark question, so you have to state the formula you're using for scoring the first mark. Then we just plug in the values. Force is 600 Newton as given here, or as you used over here. So 600 divided by 800, the mass of the car, you would get 0.75 meter per second square. So this is section 1.5.1. I hope you have understood the topic of balanced and unbalanced forces, and I'll see you guys in the next lecture with another topic, basically of forces. If you have any problem, feel free to contact me. Comment it below. Take care. Allah Hafiz.